All right, guys, we're going to be moving on to the last quadrilateral that we're going to be dealing with in this chapter, and we have definitely saved the best for last. 6.6b, we're going to be talking about kites. Again, our book originally had both kites and trapezoids all in one section, and I think you'll see by the time we get done with kites today that there's a reason that we split this into two parts. So let's go ahead and get into it today. It says, I can understand and utilize the properties of kites to find unknown values in them. First of all, let me say that we have one of the great characteristics that we've been using to try to figure out what makes each quadrilateral separate and different and have its own characteristics. One of the characteristics we've really been looking at is the number of parallel sides. So you will remember that parallelograms, for example, like just the regular parallelogram, the rectangle, the square, and even the rhombus, all of those had two sets of parallel sides. And then when we got to the trapezoid, obviously we just had one set of parallel sides on those. So that kind of separated this trapezoid from the rest of these other quadrilaterals. When we're talking about kites, here's the first distinguishing factor about kites is when we talk about a kite does not have any parallel sides. So one of the first things we need to write down as far as a rule for kites is no parallel sides. Okay. So none of these sides are parallel. And it kind of makes sense because if this line was extended, obviously, then it's going to cross right here. None of these sides are parallel. Okay. But again, don't be deceived because there is tons of other things that are going on with a kite. And so in order to make it a kite, you have to have two sets of congruent sides. So two sets of congruent sides. Here's what I mean. Let's say this, we've got a side here that is 10 centimeters. We use that number a whole lot, I know. But then this one would also be 10 centimeters as well. And likewise, let's say this one was 20 centimeters. Then this side here would also be 20 centimeters, okay? So number one, a kite has no parallel sides. Number two, it has two sets of congruent sides, okay? The other thing that we have to recognize about a kite, so you're going to notice here that I have two congruent sides here, and I have two congruent sides here. The angles that are in between those congruent sides, so this angle here and this angle here, are actually congruent, okay? So it has one pair of congruent angles. And those angles, again, are between, I'd even put them in a different color here just so we can kind of see what's going on. Those are between the two congruent sides, okay? So not here. We're going to talk about that here in just a few seconds. But these angles here would be congruent, okay? And you can kind of just tell by looking at this one and this one that they are not congruent at all. These kind of look congruent, so it makes a little more sense. So one pair of congruent angles, all right? So now let's talk about what if we draw diagonals in on this, okay? So I'm going to draw a diagonal across here and a diagonal down this way. Now, just by looking at that, do you see anything maybe that could possibly be another characteristic here of a kite? And if you look really close, you can kind of see here that we would have a right angle right here. So how do we describe that? Well, the diagonals are perpendicular. Okay, so the diagonals are perpendicular. As a matter of fact, we could go ahead and say that this is 90 degrees everywhere on the inside of this. Okay, so they're 90-degree angles all on the inside of this kite. All right, so here's the other thing that we need to recognize here is you notice I have a short diagonal and I have a long diagonal. Well, just by looking at these, you can kind of see that this side here, or this angle, this bisector from here to here is not the same as from here to here. However, what I want you to notice is, and I'm going to go ahead and write this down as another rule here. Again, we're getting a lot here on one page. I'm going to go over here to number 5. So number 5, the long diagonal bisects the short diagonal. So what that means is that whatever this is, then this is also the same exact thing, okay? So again, the long diagonal bisects the short diagonal. So we've already come up with 5 different things here that's happened with this one little figure, all right? But we got one more to go, and I'm gonna go ahead and do this in a different color as well. Let's see, let's do this in red. So if you will note right here that this angle and this angle are the same. And you have a similar situation here. You have where this angle and this angle are the same. All right, so let's try to put that into words to help us to describe what's going on here. So the vertex angle, remember the vertex is just where 2 rays meet. So the vertex angle between the congruent sides is bisected. Okay, so let's go over that again. Vertex angle between the congruent sides. So these angles between the congruent sides, here was my congruent sides. This complete angle is bisected right down the middle. So let's just go ahead and put some numbers in here just to make sense out of this. If this particular angle right here was 34 degrees, then we would know that this angle here is also 34 degrees, okay? If this angle here was 15 degrees, then we would know that this angle here is also 15 degrees. So tons of properties here that you can see just from one figure, just from this kite, okay? So let's walk through a couple of examples here that I think will be helpful when you get into your practice. Actually, these come from your practice, so you're going to get 2 of these at least correct for sure. So let's look at one example here. Just call it example 1. And I'm going to go ahead and draw this out real quick. Wow, that was kind of terrible, but so we're going to go ahead and mark our congruent sides here. Okay, and here's what we're given in this particular problem. We're told that this is 101 degrees, and we're told that this angle inside of here is 48 degrees, and we're asked to provide angle 1 and angle 2. Okay, so those are not angle measurements. Those are actually what you're expected to try to find. Well, let's go back to our rules for just a second. What do we know about these 2 angles here that are between my congruent sides? All right, so if I go back to my set of rules, we determined that there are 1 pair of congruent angles, and notice they're right here in blue, okay? So we know that those 2 angles have to be congruent. Well, that helps us here because that means whatever angle this is, this angle has to be the same. So 1 and 2 are going to be the same answer. So I don't really know what 1 and 2 are right now, but I could call them X, for example. And if this one is X, then this one also has to be X. So let's just think about the rules about a quadrilateral. Quadrilateral, we know, with 4 sides, it has to add up to 360 degrees. So here's how I would set up my problem. I'm going to go ahead and take the 101 that I have right here, plus the 48 that I have right here, and I'm going to go ahead and add X plus X, right? I've got 2 of those, and all of that together should add up to 360 degrees. So now I've got the basis for my problem. Again, I'm just going to collect some like terms here. I've got X and X, so that makes 2X. I've got 101 and 48. That equals 149. And again, it is still all equal to 360 degrees. So now I simply just subtract my 149 from both sides. I'm going to get 2X equals 211. Yep. And so I'm going to divide by 2. And when I do that, I'm going to figure out that X equals 105.5. Okay, and that's okay that it come out to a decimal. It's all right. That's perfectly fine. So that means that each one of these angles are 105.5. So this would be my answer right here. Okay, so now let's look at another example here. We're going to be given some information in this one as well, and we got to try to use the rules to help us to figure out exactly what we need to do. And this one's kind of a kitchen sink problem. It's got a little bit of everything on it. So this one, again, the kite is kind of turned on its side, but it's okay because they're going to give us at least some marks to help us to see what we need to do. Okay, that's kind of a terrible drawing, but you get the idea. So you notice right here, all we're given is this is 51 degrees. We're asked to find angle 1. We're asked to find angle 2, which is right in there. And we're asked to find angle 3, which is right there. Okay, so let's take this one step at a time and let's think about our rules and think about what we can do here. And let's just go ahead and start with angle 1. Okay, angle 1 is the first one we need to try to figure out. What in the world is this angle right here? Well, again, let's go back to our rules for just a second. And let's see if there's anything that's going to help me here. Now, again, my kite here is kind of turned different than this one is, but it's okay. I've still got the same situation. And notice that number 1 was right down in here. What do we know about these angles inside of here? Well, we learned that the diagonals are perpendicular, okay? So because the diagonals are perpendicular, just because of that one rule, I know that angle 1 has to equal 90 degrees. This angle right here has to be 90 degrees because the diagonals are perpendicular. So that was pretty easy, okay? Now I'm going to go ahead and move to number 2 here, okay? So angle number 2, I want to think about the fact that if you look at this and you can kind of, let's do this. Let's shade this one right here just a little bit so you can kind of see that. Let's just focus on the green triangle right now. Well, if you focus on the green triangle and you really think about what you have, really what you have is you have nothing more than an isosceles triangle, okay? And you notice that the angle right here happens to be 51 degrees. Well, if that angle is 51 degrees and it's across from this side, then what does this angle have to be? It also has to be 51 degrees. So just because of the past knowledge that we have about isosceles triangles, we know that angle 2 has to be equal to 51 degrees. Okay, so those two properties alone have helped us to try to figure out this much of this triangle. Now we're thinking about number 3 here. And remember, we already decided that this one is 51 degrees. We've decided that all of these angles inside of here, because the diagonals are perpendicular, this has to be 90 degrees as well, which means now I can use the triangle equality theorem, which just says that all triangles add up to 180 degrees. And now my focus is going to be on just the top triangle, okay? Now I'm just focusing on this part of the triangle. And so I have 51 plus 90 plus something, I don't know what it is, and it has to equal 180 degrees, okay? So if we go ahead and do this math, we're going to get 141 plus x equals 180. Subtract 141 from both sides, and I'm going to figure out that the angle that I'm looking for is actually 39 degrees. Okay, so again, kind of using everything that we've learned in the past about triangles. Remember, I told you, you're not going to get done with triangles. Triangles are going to be here forever. But even though we're dealing with kites, we're still using some of those same properties to help us to figure out some problems here. So again, hopefully this is helpful to you. If you have any issues or any problems as you get into this, then please make sure that you reach out to us. We'll be glad to give you some help on these particular questions. All right, have a great day today.